Great. So we are up to our third and last speaker for this session. Great. Hello.
Hello. Hi.
I'd love to introduce Joanna Mielichik. Have I pronounced your name correctly?
No, but it's still fine. It's a
Okay.
Polish name and it's pretty complicated. It's Milewczyk, but yeah, everybody has
Mielichik.
their own version.
Okay. Well, yes. She is the digital business partner at Three Your Mind, and will be presenting for us on-demand manufacturing doesn't occur overnight. So with that, would you like to share your screen?
Yes, absolutely. And please let me know. Yeah, it's my third TIPE conference, but first time being a speaker, so I feel like a newbie here.
Aw.
Okay, let me quickly do that. Hopefully you can see, and I will go to the
Yes, I see your screen.
to the presenter mode. Yes, okay, we are here. Perfect. Okay. So, hello everybody. Thank you so much, Nagin, to to have me here. And yeah, and today I wanted to present the topic that we are focusing on in Three Your Mind for years right now, which is on-demand manufacturing, and why it's doesn't occur overnight, and why do you need to follow specific steps and also use the technology stack to move forward if you want to start producing parts, especially replacement parts and spare parts on demand. So the presentation I will try to keep it quite simple, and I have a main point. So first of all, I would like to talk about supply chain disruption and the state of the industry, what is currently happening, why on-demand manufacturing is on the rise, and why it's the most popular way to to kind of make your supply chain more resilient. I would like to talk about our solution as a second step, and how we recommend to start, for example, with on-demand manufacturing, and why using additive and on-demand manufacturing makes sense nowadays, and also touch upon the challenges and the results that we have in various industries, especially in railway, energy, and defense. One second. Yes. Yeah, so traditional supply chain, it's very complicated, and it's very unsustainable and unstable at the moment. So we all heard about, different troubles, different problems, like, of course, COVID-19. I mean, I don't need to mention that. The blocked Suez Canal, or, or problems, for example, related to the war in Ukraine. So the parts that could be produced on demand and whenever and wherever they are needed, they're actually produced in different parts of the world and then shipped, to the final location just in the system, just in time. And that means that everything needs to work perfectly, so that the final product will be assembled in the right time, in right cost, etc., which is not happening nowadays, unfortunately. So therefore, the production on demand is on the rise, and we see that more and more companies are trying to use the technology like additive manufacturing to produce parts, and store them digitally instead of physically in their warehouses. So according to latest study of McKinsey, actually maintenance legacy fleets and equipment is up to 50% of overall operational costs, which is very big amount. And also unexpected downtime costs reaches around $50 billion per year. As well as 42% of all incidents are caused by equipment failure. That means that, for example, in the industries that I mentioned before, like railway and energy, etc., where the parts are quite complicated, are quite large and specific. Those kind of costs are, they will of course increase the final cost of the operations and also the final product that we are using. So also according to Forbes, unexpected downtimes currently cost companies up to $3 million per incident, which is also a very costly thing. It all depends. Like we all depend on the supply chain and how badly or well it works. So I found a very interesting report by JBL. It was published a couple of weeks ago, where actually JBL suggests that the companies that they want to keep on top of their game, they need to actually invest into digital technology stack and support their supply chain. And with well-planned technology and stack in place, businesses can integrate logistics data and change them very quickly, strategically, and efficiently when supplier, for example, cannot supply the parts anymore. And here also, it's very important information that 80% of all of the companies are considering or they already applied some software to help there with the product and supply chain planning. And therefore, we need to, with that technology stack, we have to think about creating the more resilient supply chains with on-demand manufacturing. So overall, what is on-demand manufacturing, and why is it important actually to move your production towards it? So on-demand manufacturing produces low and mid-volume goods like spare parts, replacement equipment, and other, when and where they are needed using advanced technologies, for example, like 3D printing, CNC, and others. And the widespread adoption of on-demand manufacturing requires changing the current manufacturing method and processes to evolve in close harmony with the Industry 4.0 and, for example, decentralization of the information, interoperability, big data, and the industrial Internet of Things. And why is on-demand manufacturing important? Because the on-demand manufacturing methods, as I mentioned, like additive manufacturing, for example, can step in and produce parts with a shortened production lead time and less operational downtime, which is the very important thing for when you think about producing, for example, spare parts. So the potential of on-demand manufacturing and additive manufacturing in general, additive technology, to support on-demand manufacturing initiatives is gaining high level of support in government. So for example, in May of 2022, President Joe Biden announced a program to foster adoption for advanced manufacturing. And that means that the main reason behind it is to accelerate the adoption of additive manufacturing technology between major OEMs and also the SMEs, which are the suppliers. And the partnership program is designed for OEMs to send kind of like demand signals to SME suppliers to encourage suppliers to invest more into AM technology with less perceived financial risk. That means the orders will come and they are secured. That means the smaller companies can hire people, can train them, can also buy machines, and make sure that the investment will be positive for them. You can see also on the right side in the slide, you can see other initiatives. I'm not gonna go deeper into that, but feel free to reach out to me later on if you want to know more about that. So why 3R Mind is into on-demand manufacturing in general, and how we are helping companies to move on with the topic. So here you can see that 3R Mind introduced the part screening and business case and part identification, and we have the whole technology thread, which covers whole on-demand manufacturing process. So 3R Mind empowers companies actually to start with on-demand manufacturing by enabling them to identify parts which are suitable for additive manufacturing, for example, and other advanced technologies in the amounts that are required, and playing to the benefits of the production technologies. So here's the overview, as you can see. And I would like to focus now on the first part, which is identifying parts for on-demand manufacturing, and why it's important to focus on the right applications from the get-go, to make sure that the whole investment makes sense overall. So with 3R Mind algorithms that are calculating the business case for on-demand manufacturing, it's much easier actually to find, among the, for example, thousands and tens of thousands of parts, the right ones. As we are collecting data, for example, and we are, bringing the structure and enabling companies to make sure that, for example, they are able to find like around 10%, 12% of the parts from their inventory that they can start with that make sense business-wise and technology-wise. So we always, encourage companies to make sure that they are analyzing those two. So first of all, economical data and technical data as well. So we are calculating the total cost of the ownership, which is very important. That means, how many, for example, we are calculating how many people, for example, are working on specific part, and what is the complete cost of the part produced with additive manufacturing in comparison to the traditional technologies. We have the various of data inputs, right? So we have two approaches to that. We have top-down and bottom-up approach, which I will talk about a little bit later, talking about the business case of SNCF and Deutsche Bahn. In the software, we have also technology suggestion, analytics, central database, and collaboration and communication. That means that everything that is happening around part identification is happening in one platform, and all of the communication, all of the knowledge about additive manufacturing and on-demand is in one place, which is very important, especially for large companies, where we saw many times that, for example, the parts are, in different computers, different people are responsible for different parts, and overall, the information is not centralized, which is not allowing for scaling up. Then part qualification management. So we have here, so to be able to actually move parts to on-demand manufacturing, first of all, the qualification needs to occur. Either it's a spare part, replacement part, a new part. The qualification is very important. So we make sure that all technological data is there, and all the quality requirements are met by the companies. So you can see, for example, that we are supporting also the companies with the 3D design and viewer, the different quality checks and documentation management, so that all of the information, all of the recipe for the part is in one software, in one place. Ordering parts with digital inventory management. This is also very crucial. So once we identify the parts, once we have qualified them and make sure that, for example, they are available, they are available to be ordered on demand with our order management system. And this is more or less how it looks like at the moment. So you have the whole inventory of parts, for example, in one place, and thanks to the connection with different suppliers, we are able to connect them and to make sure that the order is taking place. So the digital inventory actually allows companies, so big OEMs, first of all, to have all of the information in one place, and to make sure that parts are stored in a secured way, and are easy to be found by different people, for example, in the company. Either it's a purchasing manager, it's a production manager, or supply chain a person. They are able to come in and check, for example, if the part is available on demand, or, for example, they still need to order this via traditional methods. And production of parts on demand. So the last part of our software is actually quality management with sorry, digital shop floor management. That means that we are able to with the software to produce parts and to schedule jobs, for example, and thanks to machine connectivity, also make sure that we are managing the whole shop floor. For example, imagine some of our customers sorry, have hundreds, sometimes of 3D printers in one place. And thanks to machine connectivity, they are able to see again in one platform, what is happening on the shop floor, which, for example, machines need their attention, and which, for example, finish their jobs, etc., etc. So, so as I mentioned, like our customers, mainly from the 3 verticals, from 3 industries, are using on-demand manufacturing on their, to their benefits, right? So, the customers are operating fleets that are usually 25 plus years old. And we are talking here about different trains, for example, the oil drills, stations, and different equipment, for example, in defense. And those parts and this equipment is very, very critical. Either it's about transportation, or oil prices, or even operations in the militaries. So here's, for example, a couple of examples of our customers that we are working with. They are using 3YourMind platform to identify parts and stored parts digitally, again, and make sure that for example, their production is right in time, and the products and the parts are available at all times. A great success story of Deutsche Bahn is one of our flag examples of how the on-demand manufacturing and additive manufacturing can be used to the advantage of the company. So so I was talking previously also about top-down and bottom-up approaches. So Deutsche Bahn actually had a big problem because they wanted to start with additive manufacturing, they wanted to start with on-demand manufacturing, but they were not able to do so due to lack of data and lack of central database based on which they could calculate, for example, which part parts can be moved to additive manufacturing. And therefore, we help them. And thanks to our application, they were able to, in different MROs and in different locations, for example, they were able to, use the knowledge and the will of their employees that submitted parts that, in their opinion, could be suitable for additive manufacturing. And thanks to that, they built throughout months and years, they were able to build the database of the parts that are at the moment produced with additive manufacturing. So overall, the results were pretty impressive. So inflated, for example, warehousing costs due to obsolete and slowly rotating parts shortage, storing. Which were needed, for example, within 1 or 5 years were reduced, and they started being stored digitally. And for example, we improved definitely the identification and speed of identification to AM from 50 to 1 to 3 to 2. Also increased the time of the of the part assessment. Reduced time of the of finding the use cases, and also saves money according to in comparison to traditional methods. The other example is SNCF, where we had the data, but the data was, for example, very unstructured, and we were thanks to our our consultants and our software, of course, we were able to help the company actually and have the inventory analysis in a quite large scale. And we were able to find very interesting business cases, and that actually make sense business-wise to start with, because usually additive manufacturing is related to a very fancy parts, for example, that are very complicated, etc. But in the industries, for example, like railway, energy, and others, usually it's the opposite, right? Usually it's those are the small and the very simple parts that are actually make sense economically to move them to additive manufacturing, and then of course later on move with other parts, more complex parts. But at the beginning, we usually see that to start and to also show the management of the companies that additive manufacturing makes sense, and it's a technology that should be invested in. They need to see the positive ROI first of all, and this is what we are helping companies of doing so. So here, for example, we in SNCF we are able to generate 20.3 million euro of ROI, which was of course pretty impressive. That's why company is it's still with us and growing. In the energy industry, also the equipment, is quite problematic, same as in the railway, for example. So in the railway, we have very old, locomotives and wagons, etc., that need constant maintenance. In the energy, on the other hand, we have equipment that is, it's very difficult actually to maintain it due to the remote locations, and also quite complex and quite large, for example, equipment and parts. And here is a couple of examples of companies. Unfortunately, we cannot talk about like all of them, but the ones that we can mention with the name, of course we do. And oil and gas is actually using on-demand manufacturing, additive manufacturing, to their benefits in a very, very large scale. as they have various locations, and as I mentioned, they are remote. So it's always good to to have, for example, equipment on demand. And usually parts, as we know from our customers, usually parts that are quite complicated, quite complex. Sometimes it can take up to 12 months, for example, to produce those kind of parts. And of course, downtime is very costly. Therefore, on-demand manufacturing is the perfect solution to those kind of companies. And of course, in defense, we have plenty of examples, of how defense is using on-demand manufacturing. So, as I mentioned before, for railway and energy, here in defense, we also have a lot of times remote locations. We have problems that for example, the parts are needed right away. We have very limited storage space. So instead of, for example, taking the equipment and taking the parts as the operation go, it's definitely easier to have boxes of filaments and produce parts where and when they are needed, instead of having them, for example, and shipping them from one place to another. And as a conclusion, the on-demand manufacturing, of course, doesn't happen overnight, and thanks to software like ours, it's possible to store parts in the secured way, in the digital format. If you would like to know more, please contact me. Here is my contact information and email. I will be happy to answer the questions if there will be any.
Thank you so much, Joanna. That was really cool. I'm so glad I got an insight into what's happening at 3 Your Mind and a different industry perspective in this session. So lots of people also found it interesting, and there's heaps of questions. So I'll start by asking you, what are your key qualities used to decide whether a part can be produced by additive manufacturing?
Yeah, sure. So for years we were working with different machine manufacturers, and we gathered a lot of knowledge about how, for example, which parts can be produced with which additive manufacturing methods. So in our software, we have inbuilt the part assessment and technology requirements, etc., etc. So this is mainly based on the examples that we had so far, and because in our software we are storing at the moment thousands and thousands of parts, we are able, based on those previous parts, also learn what kind of, for example, what kind of technology will be suitable for additive for the future parts.
Great. The next question is, how do you deal with different company part labeling? For example, not all part files will have the dimensions, material, etc. included, and every company has a different labeling system.
Yes, that's quite problematic. Of course, it's usually a big challenge, of course, and we are working therefore on the project basis. So we know the software is not out of the box solution. We always have for example, the project manager working, and our amazing customer success team working together with the customers to ensure that we understand fully what is the labeling, what is the system behind every company, and therefore we are able to also bring our structure, right? So it's usually the start of the project. It usually takes like 3 to 6 months, for example, to understand each other, first of all, to make sure that we are speaking the same language, and we know what is our goal for the project, and therefore and then moving with implementing and actually personalizing the software for each company.
Great, great. The questions are just rolling in. Do you have a specific algorithm for different types of industries?
Yes, yes. So the actually depending on the what kind of parts are needed and what kind of quality assurance is needed. For example, yes, we have a different approach to each. Some of them are focusing on the plastic parts, some of them are focusing on metal parts. Some of them are also they have quite complex, for example, the quality checkup, right? So yes, so we are definitely making sure that we are matching the criteria for the specific parts, especially for defense. Here also, like maybe I didn't mention during the presentation, but the security is very, very important there, right? So like we have to also meet all of the criteria, to make sure that we are storing all of the parts in the secured way, secured manner.
Right, cool. How do you support companies with quality checks? What sort of qualities do you check, and is it post-printing or using print monitoring?
So it's usually like per part, for example. So each part that is coming out, for example, from the production, we have a specific quality check sheets that can be either can be printed out and can be done on paper, of course, but also in our application. And yeah, and it also depends on the on the industry. So if we are talking about, for example, parts that are for the medical industry, right? So of course, like each of them needs to be checked. And there are some parts, for example, if we are talking about prototyping or some others, where this quality check is not needed. So in our software, we have a different workflows for different various of parts, and then the quality check can be like assigned. Specific quality check can be assigned to those workflows and those jobs. Yeah.
Cool. There's just two more. How fast is the turnaround of the 3D parts for small and large quantities?
I don't get the question.
Okay,
Maybe
I think it's what they're saying is how fast is the turnaround time of the 3D printed parts? So how fast can you print small quantities and large quantities of parts?
Oh,
Or
that's depend on the machines. It's
yeah,
yeah, it's software. I mean, like it's a separate thing. That's why maybe I didn't understand the question properly. But yeah, but that depends on the you know what is your how is your shop floor, right? So and also, for example, as I mentioned, like we have the order management system where you can connect with different suppliers, and you can actually produce parts, with the supplier. So that also depends on their capacity. A lot of companies, for example, that are focusing, for example, they have printing in-house only in the plastic technologies. For example, when they need a metal part, they usually don't put their hand and don't start with metal printing. They usually use other suppliers to prepare that part, and they are using their knowledge and their machines to do so. And this is the beauty of on-demand manufacturing. You can always have everything in the digital format, and then order from the shop floor, that the service bureau, for example, that is, I don't know, a couple of kilometers away from you, and not, for example, produce parts in Malaysia or somewhere in Asia and ship them in the time, for example, of 3, 4, maybe more months, and lose time on that.
okay, all right. Well, Joanna, you've been a champion answering all those questions. Thank you so much for
Thank
your
you so
time
much.
and your insight. I'd just like to say that this wraps up our block for this session, and we have a 2-hour break for networking. And then when we come back in the technology track, it'll be Katrine Woody talking about a concept of green powder bed fusion of metals through beam shaping. So I'd like to wrap it up and invite you all to go to the main stage. And thank you, Joanna, once again.
Thank you so much. That was a pleasure
No,
to be here. Thank you for inviting me. Thank you.
no worries.